today is going to be all about high-rise concrete buildings. Like Maria said, it's two parts, part one and part two. And we're going to go ahead and start with the first slide of this. Just a little bit of a background on the CKC. Kerry Kapczynski Company is a structural engineering firm based in Seattle. We have offices in Seattle and Chicago, and our expertise is urban infills, high-rise buildings, and basically parking structure, and our bread and butter is concrete buildings. So as you can see here, we have a combination of a put together of high-rise building in the U.S. and beyond. This is this is in Abu Dhabi, and these buildings are a combination of residential, office buildings, mixed use, hotels, and retail. A lot of our buildings are on the West Coast, as well on, we have several under construction right now going on other parts of the U.S. So with that, let's talk a little bit about concrete buildings and what's going on with the high-rise concrete building and the trend. This is a graph from CTBUH showing basically the progression of concrete building in the past 60 years or so. So as you can see on the graph right here, is building above 330 feet, considered per CTBUH as a high-rise building, and the number of them in the United States starting from the 1960s to the present time. The blue represents steel, the red represents concrete, and the green represents a hybrid system of the two, composite system. And you can see back in the 60s, steel was predominant, and then concrete was less. And as we move forward to the 80s and 2000, you could see that in the 1980s to 2000, concrete started taking over. And 2000 till present, you had a big a jump in concrete high-rise constructions compared to other material throughout the U.S. So this gets you to wonder, why is that? I would attribute that to three things. There's a lot of factors involved in it, but basically material technology is critical. When you go with high-rise buildings, you have more loads, heavier loads, and so on. So having high-performance concrete and high-strength concrete is critical. In my mind, the most important thing is number two, construction technology and advances in that. Imagine yourself, you're building the Empire State Building back in the turn of the century, 1900, and try to bucket the entire building. That would be tough. So the technology of pumping concrete is major in advancing the concrete into the high-rise arena of buildings. Formwork is a huge one. Imagine back when you have to hand set everything and you didn't have formwork, you have to build it all out of plywood. And why formwork is big, and we'll have more talk about that down in the constructability section of that webinar, is because formwork constitute about half or more of the cost of a concrete structure between labor and material. And design technology advances. And that is an important one, a very important one for engineers who design buildings. The understanding of the behavior of concrete building has dramatically improved from the 70s till today. Prior to that, if you look at the West Coast, concrete buildings were considered brittle and not able to sustain a lot of loads under seismic events. And the behavior and understanding of concrete building has advanced quite a bit. And you can see it within the codes itself, understanding of concrete ductility and how that behaves and dissipate energy has helped at least the concrete buildings to become dominant in high seismic regions. And obviously the improved design tools. Instead of using punch cards and calculators, now we have a lot of good design tools that help understand the behavior and help us do some exotic designs using concrete. So with that, that shows you, here's a collection of high-rise concrete building on the West Coast that CKC has done. And you can see quite a bit of them here. The top left one is right by the Staples Center. Is 2 twin concrete towers, 420 footers. Then you have 1900 Broadway's in Oakland coming up off the ground right now. It's about a 450-foot tower. Lincoln Square South is a compound that represents 2 450-foot towers. Both of them have concrete lateral systems, and the Vermont in Los Angeles as well. So that shows you that would not have happened back in the 80s or 70s to build these big towers efficiently on the West Coast. So the scope of this presentation, I will break it up into 3 parts. There's a subsection to each one.